Hello everyone and welcome to another episode of Investigation. In today's episode of Investigation, I'll go over a 2021 fall AMC 10B number 21, which also appeared on the 12B test as number 19. So it states that rectangular polygons with 5, 6, 7, 8 sides are inscribed in the same circle. No two of the polygons share a vertex, and no three of their sides intersect at a common point. And it asks how many points inside the circle do two of their sides intersect. So the first condition that they gave us is no two of the polygons share a vertex. And we can utilize that because if two of the polygons have the same vertex, let's just say these two polygons have the same vertex, then how do we know if, well, first of all, if this point should be counted? Well, from the wording language, it says, how many points inside the circle? So this point should not be counted. So it will create a kind of confusion, but over here, we are cleared up that nothing like this happened. And more importantly, we will have the second condition that they gave us. No three of their sides intersect at a common point. So we don't have to worry about over-counting any of the intersection points. So if we count each pair, let's say if this does happen, if we count each pair like so, we will have one pair, two pairs, and to finish it off, we have like this, three pairs. So we will count as three intersection points. Well, in fact, there's only one intersection point. So we don't have to worry about this at all either. Which means that we can split this complicated graph to 6 different subgraphs, and each of those intersection points will be unique on the combined graph. Here's what I mean by it. So, first of all, we take a look at 5 and 6. I'll just try my best to draw. Here is a hexagon, and I will draw my pentagon for 5. If you count the number of intersections here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You will find out that there are 10 intersection points. But why is that? Well, if we take a look at it in the perspective of the pentagon over here. So if we have the pentagon over here, then for this vertex to go to the next, if we connect it with the center, we will see that this angle is going to be 360 degrees divided by 5, or rather, it is just going to be 72 degrees. So over here, we have 72 degrees. But if we look at our angle of this hexagon, just to make the diagram a little bit cleaner, I'll use another angle. It's all of the same because this is a regular polygon. So this is going to be 360 divided by 6, which is 60 degrees. Even if you start right over here on the edge and you go 72 degrees thisward, you would go through at least one vertex of the hexagon over here. And if you want to go through one vertex, you need to go over first and come back, which would result in 2 intersections. Now, there are 2 intersections per side that we have over here. And how many sides there are in a pentagon? Well, there are going to be 5 sides. So there are 2 times 5, which is equal to 10 intersections total, regardless of the configuration that we have over here. Well, if you think about it, the same thing would happen when you have 5 and 7. Why? Because the central angle is going to be smaller. It is going to be 360 degrees divided by 7, and that is obviously smaller than 72 degrees. So for each side of the pentagon, we would have, well, you guessed it, 2 times 5 equals 10 intersections. Same thing happens with 5 and 8. Well, we know that 360 divided by 8 is less than 72 degrees. We would again get that 10 intersections. Now, let's move on to 6 and 7. If we have 6 and 7, then we no longer have 72 degrees present, but the 6 will yield a 60 degree, and 360 divided by 7 is less than 60 degrees. So we are looking at the hexagon as our subject here, which means that over here we have 6, and for each side we will have 2 intersections, which would give us 12 intersections. And over here, if we have 6 and 8, well, the same thing happens. It's less than 60 degrees. We would have 2 times 6 equals 12 intersections. And lastly, we have 7 and 8. Now, in this case, 360 divided by 8 is less than 360 degrees divided by 7, which means that over here we have 2 times 7. And by far, I think you have seen the pattern, although we don't need it for this problem. But for every 2 polygons, regular polygons, you will see that we take the one with the less side length and multiply that last number of sides and multiply that by 2. Well, the reason that we cannot take the one with more side length is because, well, you see over here, if we look at the hexagon instead, if we look at the hexagon over here, you see that not every side intersects with the pentagon 2 times. For example, over here on this side, it only intersected 0 times, which means that we cannot do 2 times 6. And that counting will be a lot more trickier than if we just look at the pentagon in this case. Anyways, if we sum up all of these numbers, we get 30 plus 2 times 12, that's 24, plus 14. And if we add that first, we get 30 plus 38, which is going to give us 68, which is our answer choice E. Thank you for watching this episode of Investigation, and I will catch you in the next one. We'll go over 2021 Fall AMC 10B number 22. Finally, we are getting to the hard problems on the AMC test, so be sure to not miss it. And that's it for today. Goodbye.